Okay, welcome back from the break, everybody. I would like to introduce our second speaker for this afternoon's session, Gregory Jenkins, who is a professor in the Department of Physics and Astronomy at Howard University in Washington, D.C. Dr. Jenkins?
Thank you very much. Good afternoon or good day wherever you are. I want to give a presentation which talks about the use of Giovanni for looking at air quality in West Africa as it relates to summer and winter season Saharan dust events. So I'll start out with an introduction and the motivation for this work. Saharan dust may pose a significant health risk for both transmittable and non-transmittable respiratory disease in West Africa. This is a region that is considered data sparse for aerosol monitoring. It has a very limited public health care system, as we've found out is the case with Ebola in some of the countries like Liberia and Sierra Leone. And further, we need a way to quantify the near real-time products of visible images and some of the UMETSAT products. We also have ground-based sun photometers, and eventually we want to do hindcast with models, aerosol models. So the region of focus will be the country of Senegal, but in general, I will look at the entire region from Senegal in the west, which is located here, all the way across to Chad in the east and down to the coast. So Senegal in particular, again, is a coastal country, and there are three places that I want to point out for you. The first is Dakar, which is the capital of the country, and it's also where we have particulate matter measurement. The second is Mbour, which is about 75 kilometers to the southeast of Dakar, and there is an Aeronet site there. The third place is Touba, which is a religious center in Senegal, and each year there are large ceremonies and large groups of people that go there for the ceremony. Now, about Giovanni, it is a tool that can be used globally by users all around the world, and it's especially useful in places where there is a limitation on the bandwidth. So it allows you to do analysis online and to plot out files. You could also download the data once you have a sense of what you want. There are a number of products that are very useful for examining dust over West Africa, and those include the MODIS products at both daily and monthly timescales related to Terra and Aqua, and the OMI satellite has products at a daily timescale, which are also very useful, and they can also help us to distinguish between aerosol types like biomass burning aerosols versus dust aerosols. The products are also available for both land and ocean, and for land, Deep Blue is a very useful product. The variables that are important include aerosol optical depth, the angstrom exponent, the single scattering albedo, the UV index, which is associated with the OMI product, and the aerosol optical absorption optical depth. That's also a very important product. I just want to acknowledge that the analysis and visualizations that are used in the presentation here were produced with the Giovanni online data system, and that system is developed and maintained by NASA, GES is. So the picture that I have up next shows you that there are various sources of dust that can impact West Africa, it can impact the region at any time of the year, but in particular, the winter, spring, and summer seasons are when we see dust outbreaks. So during the summer and spring, these areas towards coastal West Africa are impacted. In addition, we see dust sources to Europe. That typically happens during the winter and spring seasons. And then finally, we have dust down towards the coastal zones from this large source, which is the Baudelaire Depression. This is the largest dust source in the world that brings dust down to coastal West Africa during the winter and spring season.